A tiny invisible guest is racing toward Earth, at nearly the speed of light. It's a black hole, but not the giant kind you're thinking of. This one is smaller than a coin. Yet it carries the mass of an entire planet. So the question is, could something that small destroy Earth? Black holes come in many sizes. Some are born from dying stars' collapsed cores with insane density. One of the closest known is Gaia BH1, just over 1,000 light-years away. It's about 10 times the mass of our Sun, yet only about the size of a city. That's the terrifying truth. Black holes aren't dangerous because of size. They're dangerous because of mass. Now imagine something even stranger. A primordial black hole formed just after the Big Bang. So small you couldn't see it, yet incredibly dense. Let's take one with the mass of Earth. In reality, it would be just 2 centimeters wide. Smaller than a coin. And if it flew past Earth, you wouldn't even notice it until it was too late. As it passes, its gravity stretches our planet. The side facing it pulls harder than the far side. This creates tidal forces strong enough to crack the crust. Even without a direct hit, it could trigger earthquakes, volcanoes, and massive tsunamis. And worse, it could knock Earth out of orbit. Too close to the Sun. Everything burns. Too far away. The planet freezes. But what if it doesn't just pass by? What if it goes straight through Earth? Then everything changes. The black hole punches through the planet like a needle through paper. In less than a fraction of a second, it creates a tunnel straight through the core. Everything near it gets stretched, pulled apart atom by atom. This is called spaghettification. Shock waves ripple across the globe. Entire tectonic plates shift. This isn't one earthquake, it's the whole planet breaking at the same time. Now scale things up. A black hole with the mass of 10 suns. Still small in size but far more destructive. As it enters the solar system, chaos begins hours before impact. Planets feel it first. Orbits shift. Gravity distorts everything. Even the night sky changes, stars appear bent and warped. That's gravitational lensing. Then it reaches Earth. The ground begins to stretch. Oceans rise unnaturally. Seconds later, everything breaks. The crust fractures across continents. Massive earthquakes erupt everywhere. If it passes through Earth, a superheated tunnel forms. Oceans boil. The atmosphere ignites. Earth survives but barely. Broken. Scarred. Changed forever. Now imagine something worse. An intermediate black hole thousands of times more massive than the Sun. At this scale, Earth doesn't stand a chance. Before it even touches the surface, gravity starts tearing the planet apart. The ground lifts. The planet collapses inward. And then Earth is gone. Not shattered. Not burned. Just erased. And finally, the ultimate nightmare. Phoenix A star. One of the most massive black holes ever known. With a mass of 100 billion suns. Its size? Bigger than our entire solar system. As it approaches, you wouldn't see it at first. Only distortions in the sky. Light bending. Stars warping. Then the effects begin. Outer planets drift off course. Earth's orbit destabilizes. Tides rise beyond anything in history. The atmosphere starts to tear away. Satellites fall from the sky. At closest approach, for just a moment, its gravity overpowers the Sun. Earth is ripped from its orbit. Everything lifts, oceans, cities, you. Then suddenly it's gone. But the damage remains. Earth becomes a rogue planet, drifting into deep space. Cold. Dark. Lifeless. Civilization ends. Not with an explosion but with silence. Black holes don't need to be big to destroy you. They just need to get close. And if one ever does, you won't see it coming.